Hello, my name is Sergit. Today I want to explain how neural networks solve the SOR problem by the gradient descent momentum and the loss function of the learning algorithm. As we know, we can solve the SOR problem by multi-persistent layers, and the step involved is forward and backward propagation. First, we need to predict our y value based on our input, and we need to compute the gradients from output to the input by using the backpropagation. The parameter needs to be the outlet is the wave. Then we see the standard gradient descent with the outlet rule formula, and the right is the gradient descent momentum outlet rule formula. Based on the standard gradient descent, if we want to compute the local minimum to be fast converged, we need to add the learning rate, but this will produce the overshoot. So to solve this problem, we can add the momentum in the gradient descent by then it will increase the gradient point in the same direction and reduce outlet for the dimension full gradient change direction. So this means it will fast to converge and produce less overshoot. So to outlet our wave, we need an activation function, and this is one of the example for the activation function. We can use the Seibert function, and we need its derivative for our activation function to outlet the wave. And next, we need to know our network is good or poor, so we need the loss function. This is the formula for the loss function. The loss function will predict the error between the y predicted and the true y, and the n is the number of the sample. So we can see the example for the graph output for standard gradient descent and the gradient descent with the momentum. If the gradient descent, it will produce the overshoot that we can see from here by re-adding the learning rate alpha. With the gradient descent momentum, the graph will be smooth and fast to be converged. So the result to predict the y value will be closer to the true y.
I'm going to talk about this regularization of the learning algorithm for the XOR problem. First of all, this technique is to overcome the overfitting, and in order to improve the performance of the model. So how this technique reduce the overfitting is that it penalize the coefficient or the weight matrix of the knot. So there's another technique that adding a regularization term as the value of weak matrix decrease, because it assumes that a neural network with smaller weak matrix lead to a simple model, and in order it will reduce the overfitting for the model. So lambda is one of the regularization parameter that it is a hyperparameter who optimize for the better result and this force the weight to decay towards approximate zero. So in the image above, we can see that the color of data point with x and y, x2 and x1 coordinate responding to the output of the network for input value of x and y. Green and red point correspond to the output 1 and 0, and the red dot and the green dot are the symbol represent the 0 and 1 output respectively for the actual input present in the training set. So each non-bias usually invoke an activation function that the classic sigmoid function in the case of this XOR problem. So is to squash the sum of their input value down to a value that fall between 0 and 1, but the value are usually close to 0 or 1. The output of each is including the bias unit and then multiplied by another set of respective weight and passed to the output unit. These output units are passed to the sum of the input value through an activation function. Again, then the sigmoid function is appropriate here to return to return the output value falling back to 0 and 1. That's all from me. Thank you.
Today I'm gonna present about how the learning algorithm manage the noisy data. As we know, the core of machine learning algorithm is the ability to learn and generalize from the data set that the algorithm has seen. However, if the algorithm is given enough flexibility, which is meant by more parameters, then it may happen that the algorithm will overfit the noisy data. And to avoid this happen, one common technique used is called regularization. In regularization, a penalty term is added to the algorithm cost function, and as we can see in this equation. And the lambda is the penalty term or regularization parameter, which determines how much to penalize the weight. And this ensures that for the minimization of the cost, the weight are smaller, thereby leading the lesser freedom for the algorithm. And this greatly helps in avoiding overfitting. And in order to minimize the cost, the optimizer will try to take lower value of the weight, and thereby leading to less flexibility of the algorithm. And this will avoid overfitting and also will help in handling noisy data easily. And as we can see over here, the higher the integration use, the output value will closer to the targeted output. And this is also shown in this graph.